Algebra 2, Lesson B, Parts A, B, and C. This lesson will cover perimeter, area, and volume. And the rest of the Lesson B, which is Parts D and E, will be covered in the next video. Perimeter. So a perimeter of a closed planar geometric figure is the distance around. So if we want to find the perimeter of this object, we just take all of the sides and add them together. So this particular figure's perimeter is 12.5 units. Okay, this is the radius of a circle, this is a chord of a circle, and this is the diameter of a circle. Okay, if we take the diameter and we wrap it around a circle, it will wrap around approximately 3 1/4 times. Or not 1/4, 3.14 times. So the circumference of a circle is pi times the diameter, where pi is 3.14 times the diameter. Okay, if we do the same thing with the radius is going to go around 6 times and 0.28 of the radius. So circumference in terms of radius is going to be 2 pi r, or 6.28 r. When we're talking about circumference divided by diameter, that's pi. So pi times d is the circumference. The distance, or the diameter, is circumference divided by pi. And pi is a never-ending number. It goes on forever, 3.141592654, and it keeps going. But when we talk about pi, it's just 3.14. Okay, now we'll talk about area. When you divide something up, if it's 2 units by 4 units, it's going to be 8 square units. My units don't look very square, I know. If we're trying to find the area of a circle, you can take the radius and make squares of it. And I know that if I make 4 squares, that's too much. But if I make 3 squares of the radius, it's not enough. So somewhere between 3 radius squares and 4 radius squares is going to be the area of a circle. It's less than 4 radius squares, and it's more than 3 radius squares. In fact, it is actually pi radius squares. Remember, pi is 3.14. So circumference is 2 pi r, and the area is pi r squared. Okay, so the area of a triangle, as a reminder, is base times height divided by 2. And when we look at these 3 triangles, they all have the same area because their height is 3 units and their base is 4 units. So the area is going to be 4 times 3 divided by 2, which is 6 units. Okay, find the perimeter and the area of this figure. Lines that look parallel are parallel, dimensions are in meters. And my drawings are definitely not to scale. So if we want to find the perimeter is going to be 4 plus 5 plus 7, and then we need to use the circumference. So the circumference is going to be 2 pi r, but it's divided by 2 because it's a half circle. So it's going to be 4 plus 5 plus 7, which is 16, plus 2 pi because radius is 2. So 16 plus 2 pi is 22.28 meters. That's the perimeter. Now, if we want to find the area, we need to find the area of the half circle, the area of the square, and the area of the triangle. I know it doesn't look like a square, but it actually is. So we know that it's 4, that this length here is 4, and this length here is 3. The entire unit's 7 units long, and because the top is 4, the bottom is going to be 4 also. So we can fill in those missing measurements, and then we know this length here is 4 because the radius is 2, and 2 radii make the diameter. So we can figure out the area. The area of the square is 16 because 4 times 4 is 16. The area of the triangle is 3 times 4 divided by 2, or 6. And then the area of the circle is pi r squared divided by 2. So r squared is 4 times pi. Pi pi r squared, which is 4 pi, and then we need to divide that by 2 actually. That's not on there, but this needs to be divided by 2, so it's actually 2 pi. And then 2 pi plus 16 plus 6 is 28.28 square meters. Okay, find the area of and originally the problem said shaded portion of this figure, but I couldn't get it to do a shaded portion. So in our case, we're going to do white portion of this figure. Dimensions are in meters. So what we need to do is we need to figure out the area of the whole rectangle and then subtract the circle and subtract the triangle. So the area of the whole rectangle is 10 by 15, which is 150. Then we can find the area of the circle, which is pi r squared. So it's going to be 16 pi. So we'll subtract 16 pi. And then the area of the triangle is 5 times 6 divided by 2, or 15. So when we multiply 16 times pi and then subtract that from 150 and subtract 15 from 150, we end up with 84.76 square meters. Okay, now we're talking about volume. So a cube is a three-dimensional figure whose 6 sides are identical squares. If you have a cube that is 1 unit long on all sides, then we call it a cubic figure. And if you're measuring in centimeters, it's a cubic centimeter. If you're talking about inches, it's an inch. And if you're talking about kilometers, it's a kilometer, and so on. So a geometric solid is a geometric figure that has 3 dimensions and thus takes up space. So any 3-dimensional figure is a geometric solid. Okay, so if we have a figure that is 2 units by 3 units, the area of that figure is going to be 6 square units. In this case, we're talking centimeters. Okay, if we add dimension to it, we can find the volume. So if it's 1 unit tall, volume is going to be 2 times 3 times 1, which is 6 cubic centimeters. If we add more dimensions to it, 2 times 3 times 3, we end up with 18 cubic centimeters to find the volume. Okay, so from our problem before, we knew that the area of this figure is 28.28 square meters. If we want to find the volume of a figure that has the same area on the top, that is 1 centimeter tall, the volume is still going to be 28.28, but this time it's going to be meters cubed. If we have 3 centimeters tall, then we're going to do the area of the base times the height, so it's 28.28 times 3, which gives us 84.84 cubic. And in this case I wrote centimeters, but it's actually it looks like these should be centimeters up here. So cubic centimeters. So the volume of a right solid is the area of the base times height, and that's the volume. Okay, so these pictures here talk about the different kinds of right solids that you can have. They call them right cylinders or right prisms. So if the base is an oval, then it's a right oval cylinder. If the base is a circle, it's a right circular cylinder. If the base is a triangle, it's a triangular cylinder. If it's a rectangle, it's a rectangular cylinder. And if you're not sure what shape it is, then it's we just call it a right cylinder. Okay, so if you have a cylinder that is not a right cylinder, the way that you find the volume is very similar. You need to know the area of your base, and then you need to multiply it by the height. The height is not the slant height. The height is the distance from the bottom base to the top base. So the volume is the area of the base times the height for all of these figures. Okay, if you are trying to find the volume of a cone, the volume of a cone is going to be 1/3 of the area of the base times the height. So it's exactly 1/3 of the cylinder that has the same base and the same height. Now, if we're talking about a sphere, spheres are a little bit different. A sphere is going to take up 2/3 of the volume of the cylinder. So the sphere is 2/3 times the base, which is pi r squared, times the height, which is going to be 2r. So that is going to end up being 4/3 pi r cubed. So for example, if we need to find the volume of this figure, it's going to be 242 meters squared times 10 meters, which ends up being 2,420 cubic meters. If we want to find the volume of this figure, it's a cone, so therefore we need to do 1/3 of the base of the area times the height, which is 2,420 divided by 3, which is 806.67 cubic meters. Okay, find the volume of a sphere whose radius is 3 centimeters. So we've got our figure. We know that the height of the cylinder is going to be 2r, and the radius is 3. So it's the volume is 2/3 of the area of the base times the height, which is 4/3 pi r cubed, and we know that r is 3. So 3 cubed is 27, but we can divide by this 3 here. So 27 divided by 3 is 9, and 9 times 4 is 36. So we get 36 pi cubic centimeters as the answer.